Hi all. Uh, I welcome you to the first, knowledge sharing session of CMedu. Today we have Joel Bobby, who is our sound engineering third year student from Pune campus, and he's he started working on his hardware devices and equalizer. He's building his own equalizer plugin, and today he's here to share that knowledge with us. So I would like to welcome Joel, and thanks for sharing knowledge with our students, and uh, I hope the session will be good for everyone and everyone will learn a lot from this session. So to begin with, Joel, I just want to ask you a couple of questions. That how did you start, you know uh, like, since how long you've been thinking of it, or how did it started for you, making these devices and plugin?
So hello everyone, and hope everyone is staying safe. So yeah, as Mandar sir said, like for me, since the starting from first year onwards, I used to be like really keen into hardware gear. Like it made real cool, like it looks cool and it sounded amazing as well. So I always had this thing, like I'm always a guy who, like, whenever I get something, I just open it up, see what's inside, tinker around with it, and if it breaks, it breaks. If it doesn't, okay, screw it. And I guess my parents were there to support me with that. But that kind of led on to me discovering how like as a basic, I started with an equalizer and how it actually works. And eventually I tore down an equalizer that I had here, and I sort of reverse engineered it such a way so that I could learn why certain things were kept where, and then got into actually creating my own, which actually worked. And it does has a lot of issues that I will later get onto as well. But yeah, so that's how it usually started for me, like that keen interest to find out what is exactly happening underneath.
And yeah, good to know that. And if you could tell us, I'm sure, I mean, you'll go in depth and explain what exactly you've been doing, but if you could just give us some brief about you know what exactly you are doing right now, and how is going.
All right. So to be honest, I never thought I would be so far deep into this as of yet. Like, even though it's deep for me right now, I've barely scratched the surface of this entire thing of signal processing and as it is. But how it's, I would say this lockdown was like a blessing in disguise for me, kind of thing, because I never realized that I could be making my own, like basic hardware, and it actually working, and making my own plugin that's working. And right now I had like an idea of creating my own set of basic mixing plugins that anyone can download, which is going to be open source, which I've taken the inspiration from Neve, using like the Neve designs to like create basic interfaces, but it'll be completely digital. And that's what I've been working on right now, learning how coding works, on how to create plugins, and learning juice as a fact.
Was there any what do you say, like was there any prerequisite you had in your mind?
Trust me, I have no background when it comes to electronics. I have no background when it comes to coding. Everything that I'm going to share with you guys right now is me learning for the past 1 year online, just Googling stuff. Even the equalizer plugin that I made is probably 95% just me Googling what I needed just to modify it to my needs and then put it down in code. That is like, there might be memes around how coding is 90% Google, and I completely agree that is true. Because everything is available online. Trust me, if you want to do something, you can do it. Like, right. I believe in that.
Oh, cool. So I mean, now, I mean, that is enough talking, I believe, and I think I should hand over to you. And please, just start your session and share the knowledge with us.
All right, cool. So yeah. All right, cool. So I thought I'll start off with a small presentation that I've kind of made on signal processing. And I do want to keep this as an interactive section because at the end, we'll be making our own plugin. If you guys can follow with me, we'll make our own basic plugins. All right. So let me share my screen. All right. I hope everyone can see that.
Yes.
All right. All right, so let's talk about what signal processing is. So out of you guys all, we're all audio engineers, and our job is basically to process signal. And we process signal. Signal right now I'm talking about is not only audio. Audio is a type of signal. It could be images, it could be video, it could be, your phone signal. Those are all signals which can be processed in the same way. So when we're talking about filtering, it could be filtering to reduce noise, it could be filtering to reduce frequency, it could be filtering to clear an image or clear an audio, anything. So we all came up to this factor of two types of devices, analog and digital. We always talk about, oh, analog sounds better, or analog is this, analog is that. And people say that, no, digital is, and there's always a debate going on. Okay. 1 second. All right. So let's talk about what analog signal is. If I can't really see the chat, 1 second. I don't know if anyone is. All right.
I'll help you with it if any question comes up.
All right, cool. All right, so let's talk about analog signal processing. We have all used, so I just wanted to start out. What is an analog signal? So analog signal is what we call as a process of continuous waves, or the actual electricity that is passing through, or the electricity is what we consider as analog. And when it comes to sound, so since we're all audio engineers, I think it's better to, fundamentalize everything into the context of sound. And sound itself is an analog wave, all right, because it's the air pressure that is moving across, all right, and that air pressure hits the microphone, which creates an electric signal, which is, of course, analog. And what are the benefits of analog? It is a pure signal. Like, it's as as raw as it could be, as you could say. But the side effects of that is what we'll have noise coming through the electrical signal. It could be either because of magnets, or it could be because of any other reasons. Electricity is a reason, like, that could create noises and all that stuff. So when we're talking about signal processing in the in the analog realm, all right, we'll be talking about why, like how hardware works. So right now, since Mandar sir already talked to us about, I'll be talking about the graphic equalizer, because that's what I have made right now. And the graphic equalizer has a set of, it's basically a path which you made for the signal to travel across from point A to point B. But in between it, you are giving it some hurdles, or you're giving it a certain task to do, like if this, do that. So it's kind of like coding, but in the analog realm. Okay, if you guys can follow me with that. All right. So in that, when we're talking about basic processing, we're talking about filtering. Filtering is, I would consider, as a basic analog signal processing. So we're all, used an equalizer in our life, in the digital realm or in the analog realm, whichever way, like on your phone or anything. And it has, what do you call it? The three different bands, right? The high pass, the low pass, and then you have the band pass, which is like a combination of a high pass and a low pass together, right? Same thing applies when it comes to analog digital signal. So let's talk about what a low pass filter is. All right. So as you can see in the presentation, so a low pass filter is a filter that allows only the low frequencies from 0 hertz to a cutoff point to pass while blocking anything higher than that. It's as simple as that. And there's a circuit that I've shown here where it shows a resistor and a capacitor in that series, in that line of series, when the input and output are on these sides. So you can see where the voltage, there's a thing called as V in, which is also known as your input signal. All right. So this, when your input signal is an AC signal, because sound is back and forth. All right. So it's an AC signal. So the AC signal goes through one end of the resistor and it parallelly connects it with the capacitor going out. So this is what you call as a passive low pass. There's no boosting of frequencies. There's no amplification being done. So this is like a passive low pass filter. And there's also a formula that you can derive the frequency at which the cutoff works, which is 1/2 pi RC, where R is a resistor, C is the capacitor. So you can find the values of the resistor and the capacitor, and then find out that it is at this frequency that the cutoff frequency works. Now, there's another question that I wanted to ask you guys. All right. Do you guys know why your low pass frequency starts at 6 dBs per octave? Or why it's always in the multiples of 6? If you guys want, you can write in the chat. All right, so should I wait or just go ahead?
No, you can go ahead.
All right, so there's a reason why it's always in minus 6 dB per octave. Like the basic filter that you always do always has a property of minus 6 dB per octave. So if you always want to increase the steep or the stepness of your frequency or the filtering range, you just put in another low pass frequency right next to it. All right. So such a way that you are basically not parallelly, like in a linear way, connecting all the same low pass filter, same together. So it becomes 6 goes up to 12 goes up to 24 to 36. So that's how it actually works. All right. Same thing with the high pass filter or any other filter that has, in fact. All right. So next, let's talk about high pass filter. High pass filter, as we know, is literally the opposite of a low pass filter, and you can see it in the our circuit diagram. It is literally the capacitor and resistor changing places. So if you look at the low pass filter, and we can look at the high pass filter. All right. So again, the formula is the same. All right. Doesn't matter what filter it is. The formula is always going to be the same. So the formula is always going to be the same. All right. So no matter what, we can again create a high pass filter with this same formula. So now let's talk about what a band pass is. So a band pass to anyone is like a combination of two filters together. So let's say we have a high pass filter and we have a low pass filter. What happens when you put them together? You get a band pass filter. And just like that, that's how it works here as well. So in a band pass filter, you have first you have the low pass going through, and then you have the high pass going through. Together, we get the same thing. And again, I like to point out that it's always the same frequency. So depending on what frequency you set for your that's how wide your band is. And if you decrease the frequency such a way that the capacitor or the resistance value changes, that's how the Q or the notch comes in. Like that's how the notch that you see in every equalizer is just one adjusting a resistance or the potentiometer value. So I can show you guys here. This is a simple potentiometer right here. It looks like a small dial like this. And this allows it to change the amount of resistance that goes on from point A to point B. All right. So, sir, so I like to change my camera angle. 1 second. Oops. Yeah, so I have a small demonstration here that could help actually. So see, right now, you can see here that I've made a simple, this way it will be better. I've made a simple low pass and a high pass filter, right? This is a passive low pass and a passive high pass. I have connected the input and the output right here. So we know in the input, we have in a balanced signal, we have a positive, a negative, and a ground, or the the positive, negative, and the ground. All right. So that I've signaled here as 3 different cables, all right, which can be routed to the positive, the negative, and the ground of this circuit right here. So this entire line right here is called as a circuit. So we can see how it goes to resistor 1, all right, which is connected to a capacitor, which is connected in parallelly to the negative end, and which is going out to the positive end right here. So I hope everyone can see this.
Yeah.
All right. So this is a basic filter that is cutting at, I believe it is at 720 hertz. I'm not really sure why that was the value. I guess that's because I had that. Those are the capacitors and resistors that I had at the moment. And using the formula that I've shown you before about F is equal to 1 by 2 RC, all right, 2 pi RC, all right. So we get this filter at 720 hertz because these values are these resistors are the same, so are these capacitors. So I think that that's about it for how the basic components of this. And there's also one more component that is part of this as well. All right. So now let's talk about what an amplifier is. So in the graphic equalizer that I made, so we used a thing called as an op amp. So what is an op amp? So op amp is just an integrated circuit. So just like how we made a circuit out here, all right, on this, it's a tiny integrated circuit where everything is connected to each other, which has 2 pins for the input and 1 pin for the output. All right. So its basic role is to take a voltage, amplify it to the range that you want, all right, and then give you the output. So it's basically like it's basically a multiplier. So you give it, say maybe the op amp has like a value of 5. So you give it a value of 2, it'll always give you 10. It'll give you 5 times the value that you give it. All right. So in an op amp will look something like this. In real life, it'll look something like that on the screen. All right. And I have one over here as well on my circuit right here. All right. All right. So so we have 3 elements right now. So we have the capacitor, we have the resistor, and the operation amplifier. So with these 3 things, you can make a wide range of equipments, especially when it comes to, filtering and, equalizing when it comes to all this stuff. And everyone will be wondering, I don't know if this is a thing for you, but I've always wondered why one analog device sounds a little different from the other, or why even if the value on the digital device, on the analog device says that, oh, this is at 100 hertz or something, and the output is a little bit off, or it has a different tonality to it. The reason being is components. As components change, as it tears and wears down due to time, the quality of it changes, and because of that, we get the certain tones that we need, or as an audio engineer, that's the things that we like. All right. So so now let's get into how I made the analog graphic equalizer. So I'll stop screen sharing here, and I will all right. So right here in front of me, all right, I hope everyone can see, is the graphic equalizer that I've constructed using the same principle of the formula that I've shown you before, the same circuit that has been done, just replicated multiple times for the different bands that I require. So right now, as you can see, this is a 1, 2, 3, 4, 5, 6, 7, 8 band equalizer, which goes from 20 hertz, or I believe it's 35 hertz, all the way up to 8 kilohertz or 16 kilohertz. The only reason, you can see one more thing closely, all the resistors are the same. The only changes that I've made is the capacitor. The capacitor is changed for every circuit because, again, the formula, that's how it gets to it. All right. And before I start explaining the circuit, I think the best way to explain the circuit is through its circuit diagram. And I could show you that to you right here. Share screen. All right. I hope everyone can see the screen.
Yeah, we can see the screen.
All right, cool. So see, as we see here, we have, let's start at the very top where, it starts with the, let's say we have point A, point B, point A2 and point B2. And our goal right now is to send signal from point A to point A2 or point B to point B2, because since we're dealing with an AC circuit, we need two different sidelines for that. All right. So again, using the same design that I've shown you before on how a low pass filter and a high pass filter works, I've made a band pass filter with a pretty narrow Q, well, not really narrow Q, like a 6 dB per octave notch. Okay. On both the sides. All right. So is side one, side two. All right. And you create like a signal which goes to the positive. This is the op amp right here. All right. Which is again connected together in a certain way. So we can see the value of each resistor or each capacitor that I have calculated with the formula that was mentioned before. And we're able to get that, get at each and every single band, all right, using the listing. And this is how I just replicated the circuit again and again till for the amount of bands. So for example, if someone wants to build a 100 band EQ, you can do that. Just repeat the same thing over 100 times. 5 band, just repeat it 5 times, and then so on. All right. So apart from this, okay. So now we've had a basic idea of how this is working right now. It does. If anyone has any questions, do let me know. If I'm going too fast, do let me know as well. So yeah. So then we have, yeah.
So basically, ECDA is some kind of a software that gives you PCB layout creation. So can you talk about it a little?
Well, actually, I was going to come to this. Thank you so much, sir. ECDA is basically a software, is a free open source software that I say, which allows a user to create your own circuits, and then you can design your own PCBs out of it. So a PCB will look something like this, like a green board, which allows you to solder electrical components on top of it. So it's basically like your set of wires that you see. So over here on the circuit, you see that there's a lot of wires going up and back and forth, and connecting them, just one end to the other would require a lot of wires. It'll be messy. It'll be unorganized. You won't know what is happening. So a PCB is the best way to go for it. And ECEDA is an open source software that is free to use for anyone. You guys can go online and you can create your own components here. So for example, if let's say I want to add a capacitor. All right, so so remember we talked about this circuit right here, the low pass filter. All right, so we can actually make that low pass filter right here. So we can go to a design, we can go to a component. All right, oopsie, we can search the component that you're looking for. So right now we want a resistor. All right, so let's say I took a resistor, I placed it down. Right, I can adjust the value of the resistor. I can figure out what is happening. All right, and then I could say that I want another capacitor as well. So let's say I have a capacitor. I place it down. All right, let's say I want to rotate it. All right, I rotated it. Right, and I want to keep it here. But now, how do I connect them? Of course, we use wires, and I just connect the wires to one end and the wires to the other end. So as you can see, then you can just connect all the wires together, and then that's how I made this circuit right here. All right. Later on, after we have the entire circuit has been designed, you can design your own PCB as well. So this is how the PCB that I've designed looks like. All right. We have places for the resistors, we have places for the capacitors, we have places for the potentiometers, we have the place for the operational amplifiers, and there are certain ways on how you route these cables, because these cables cannot cross each other. All right, so we have 2 layers, and you can, of course, go more than 2 layers. That's how, people make computers, that's how they make boards for your phones and all that stuff. But in my case, I've restricted it to 2 layers where I've connected. So the blue is layer 2 and the red is layer 1, where everything has been, layered in such a way that none of the cables are crossing each other. And they're all connected at a degree of 45 degrees. So there's no right angle turns when it comes to, PCB designing and all that stuff. All right. And yeah, so that's how the basic equalizer works. But to connect to the equalizer, you also need a preamp. So as everyone knows what a preamp is, it's basically a circuit which is going to amplify the incoming signal to the desired level that the device needs for it to work. So I've designed a preamp as well over here. Oops, my bad. All right. So in the preamp, we could see that we have our input. All right, we have our output, which are XLR connectors, because I wanted this to be a balanced circuit. So, and which is connecting it to your input, the input gain. All right, so this is where we have the input gain. All right, so to adjust the amount of signal that the volume of signal that's coming into your circuit. Then that is going on to your nets, which is your A2, which is going into your connecting to your the actual working PCB, which comes back into your preamp circuit board again, which is giving your output here as well. All right. So we have different nets, like the same thing on how the way I got to this design of the PCB preamp is I reverse engineered an already existing board that was available. Some of the things work because, to be honest, I have no idea, but it works because someone has designed it to work it in that way. And I just use that as a reference point to base mine off of mine. Okay. So that would be the analog section. Does anyone have any questions when it comes to analog device? Then if not, I can continue to the digital side.
Yes, you can add your questions in the chat window as well, and
yes,
we can take it from there.
All right, so I'll start the digital side as well. So if you guys have any questions, you can just keep adding it up. I'll get to it eventually. 1 second, let me. All right. So now let's talk about digital signal processing, where this is probably the part that everyone is used to. Everyone knows how this works, and why this works is, again, a mystery for a lot of people, because especially us who are audio engineers, who are, who wants to just mix songs or just producing as music producers, we just use the UI, but there is someone behind it who makes those plugins. There is someone who designs it to work in a certain way, and that is why you're using. I'm not sure if you guys had these questions, but why does emulation plugin always work in a certain way? Or why does this filter always gives the same result no matter what, but analog doesn't? Why is it consistent? Why? Like, there's a lot of questions that comes up, which I personally had when I was making my own digital signal processor. So before starting on digital signal processing, I think we should talk a little bit of the basics of digital processing, or what is digital sound? What is digital signals? So yeah.
Yeah, sorry. Before I just interrupted you, because before we move into digital, there's like 2 questions. Harsh is asking, can you talk about how you went with the wiring, connecting the components on a PCB?
All right, cool. All right, perfect. Okay, cool. No worries. I'll just stop my screen share. Just 1 second. All right, cool. So right now in front of you, you can see a PCB, which is the same as the equalizer PCB that has been kept up. All right. So this PCB is an empty or a naked PCB, you could say. There's nothing on it which has been kept here. So we can see that there's there are markings for each and every single PCB, which is designed according to mine on the circuit diagram that we saw earlier. And we could see that there are small holes and shiny parts of the holes on the thing as well. So what this does is, okay. All right. So what these holes does is these are the parts where you put in your component. So if I could take a component right now, I could show you. Let's say, just give me a second. All right. So this right here is a capacitor. All right. So this is a 50 volt 10 microfarad capacitor. All right. So let's say I want to keep the capacitor. I want to place the capacitor on this board. So there are holes on it. All right. So I can just place the capacitor in and thread them through the holes. All right. So it comes up like this, as flush as it could be. And on the other end, we get, oops, my bad. I'm so sorry.
All
right. So on the other end, the threads of the capacitors come out. All right. All right. And then we can just, using a soldering iron and solder, we can always solder the components onto these pads, these are called pads, right? There's this silver parts, which are conductive in nature. So anything with a pad, so soldering basically conducts the thing, and it basically puts this device or this component into circuit. And that's how basically the soldering is done. Soldering is, okay, so I think there's a question here.
There's one more. Yeah. Like basically, see, obviously your circuit is small. And obviously when we see any hardware, analog gears, obviously they'll have bigger circuits in that. So fundamentally, I mean, Arnav is, I think, trying to ask how it's different, your circuit, and if I see probably, any compressor or anything.
All right. So in my circuit, all right, it's DIY. All right. It has its own flaws, and I'm not a proper electrical engineer. So I'm pretty sure if there's any compatibility issues that comes up, of course, I did face different issues when it comes to, noise flow and all of that stuff. But if it's done by a proper engineer who knows his electrical signal flow like perfectly and knows why each component is going where, that makes a difference. That's what makes a clean sound come through. And when it comes to different devices, for example, like a compressor from two different companies, for example, a Teletronics compressor or a Neve EQ or SSL EQ, the difference is the circuit would be the same. All right, it's at the base of it, the science is the same for both. But the only thing that changes is the way that they integrated that science into their circuit. So SSL I haven't done much research into the SSL and the Neve circuits per se, but I could say that they get different values depending on the type of capacitors that they use, depending on the type of resistance that they use, or the quality of the resistance that they use. So that all adds up into a factor when it comes to creating a circuit. And how is it different from the big analog gears? It's not different at all. It's fundamentally the same thing. The only reason it looks big is it's just big. That's all. There's a lot more component. It's a lot more integrated. It's a lot more tight. So I hope that I answered your question.
I think now we can move into the
digital.
Yeah.
Yep. I'll just share my screen. All right. So where were we? So digital signal processing. So digital signal processing is again So what is digital signal, or when it comes to sound? It's not a signal as we have sound, or it's not something that we can hold. It's not something that we can see. Well, you can see it because it is bits and bytes, which has been written down. All right. So it's our computers are pretty efficient in translating binary code to digital signal. So we've learned about, how sampling is done. We have learned in basic digital signals, basic signal technology. We've learned how, signals has been sampled because you have your X and Y axis. And depending on the point at where your electrical signal is, your digital signal takes a snapshot of it and registers that memory there, saying that this signal, the value of this thing at this time is this much. And that's how you get the 8-bit or the 16-bit or the 24-bit. It increases the resolution or the quality of your audio. All right. And but when it comes to digital signal compared to the analog, it is clean. It is as clean as it can be, because unless a coder or a developer wants your device to have noise, there is no noise to it. You have to add everything yourself individually. So when it comes to creating a analog emulation plugin, you guys might hear, oh, that this plugin sounds better than that plugin. At the end of the day, it's the same code that has been running in the background, but the only thing changes the way how the code is written by the developer. So the developer could say, I want to have a white noise in the background, or I want to have, so when it comes to emulation, you can always, sample. That's how they take the actual analog gear. They sample it. All right. And then they put it into their software, saying that, oh, these are the parameters of my analog device. And I'll try to emulate those exact same parameters on my digital device as well. All right. So let's talk about what a digital sound is. Okay. So we have our analog input, all right, which goes into your amp or operational amplifier, which we discussed earlier, which is an analog signal, which goes through your A to D converter, which converts the electrical signal into bits. All right. And that bits and byte is processed by a microprocessor or DSP. So in this part, I'm assuming we all know everything ahead of the microprocessor, and everything ahead of that, we know that in and out. All right. And the microprocessor or the DSP is what we don't see underneath the hood. So this could include your computer or your plugin, your any other audio unit that you use to edit sound or process sound. All follows the same principle of a processor in the background or a DSP that does this work. All right. Which again, then those bits and bytes which has been edited goes back into your D2A, which is your digital to analog converter. Then it becomes into an analog signal, which goes through an amplifier to get it to this right level. And that is sent out to your analog outputs. Technically, what we see right in front of you is an interface. All right. This is how, but with the microprocessor or DSP being the computer, or if you're using like a UAD interface or the Apollo or something, it has its own DSP chip. So what we call the DSP chip, that's what this is. There's a microprocessor that is controlling your sound, or processing your sound before it goes into your computer. All right. So again, this is again what we talked about, how analog to digital conversion works. All right. Voltage over time, and we sample each one, and that's how we get the step P staircase that I call personally. And we have other issues that comes with digital signal as well. So I'm not getting into the debate of analog and digital when it comes to this. All right. So let's talk about what a DSP is. So a DSP is a digital signal processing, such as computers or a specialized digital signal processor like a microprocessor, to perform a wide variety of signal processing operations. So this can be taken into factor. It could be audio, it could be video, it could be images, whatever. All right. And DSPs operate in a few range forms. All right. We have the time domain and time and space domain, a frequency domain, a Z plane. All right. So I'm not really getting into complicated on this because we wouldn't need it, because most of them are used for other types of processing as well, not only audio. All right. But in this case, I just want to get a little deep into the Z plane, because I think the Z plane is what we would use as audio engineers, all right, and or a digital signal processor engineer for, creating audio plugins. So we basically have, because of the Z-plane, we could make digital filters, and there are two different types of filters that we can make, which is called as the IIR filter, or known as the infinite impulse response, all right, and the FIR, which is the finite infinite response. So I think we all know, I think the name of both of them, stays what it is. It's it's basically depending on the amount of input that you have, or the output, depending according to time. All right, so time is a heavy factor when it comes to digital signal processors. All right, and we can get it. So let's talk about now. If there's any questions, I'm not seeing the chat. All right. All right. Okay, so let's talk about what an audio plugin is. All right, so audio plugin to me, as of now, consists of two basic parts. All right, you have the UI and you have the DSP, or the microprocessor. So the UI, also known as the user interface, is what controls, or it's the thing that gives the parameters to the user, so that the user can control the DSP in a more efficient way. All right, so and the only job of the DSP is to take the input signal, process it to the ways of the parameters that has been set, and just output it. So it's like a simple three-way diagram of input, process, output. All right, I hope everyone can follow me on that. And so that's how we have different types of, so depending on how a person makes this program, all right, you can make it in many different types. You have VST, VST3s, audio units, AAX, if anyone's a Pro Tools user, RTAS, and TDM. All right, and there are lots of different types of ways how a person, someone could make a plugin, and usually that depends on this thing called as framework. All right, so when it comes to plugins from UAD or Waves, they have their own framework, which they have developed over the years, because they're a big company, they have their stuff. For us, we don't really have a framework that we can work on, but Juice right now is a free open source framework that anyone could use. All right, it's available to all. You guys, we can always download the Juice software and download the frameworks and the modules of it, and we can call them into our program and then do the processing that we want to do. All right, and I could I wanted to show you guys something. So I've made, so this is a graphic equalizer that I have made using this program called as Juice, or I wouldn't technically call it a program. It's more of a compiler, which helps an individual make it into a standard format that anyone can use. All right. Yes. So this is an equalizer that has been made. I believe, oopsie, my bad. All right, so this is the graphic equalizer, which I try to emulate the parameters of the analog device that I have made earlier, with the 8-band and the gain knob, all right, just to adjust the level of the audio, and with different frequencies. And I could show you that it actually works. So right now, so we're basically using a basic, how we learned about putting a high pass filter and a low pass filter. We can do the same thing when it comes to the digital RAM. All right. I believe there's a question here. Can you please tell me if you have, can you please tell if you use certain languages or codes, or some basics of set of codes that you can? Yes. I would be getting into that together. Eventually. All right, so we'll get into how I actually made it, and we'll actually make a plugin together as well. All right, I hope that's a good exercise that we can all do together, because all of these codes that are available online is it's open source. You can always read the documentation to your will and just copy and paste it. All right, and modify it to your own liking, such a way that it works with you. All right, and there's a reason why DSP right now all works on the C++ code, and it only works on C++, because C++ right now is the most stable, and the DSP modules in C++ are fast to help with real-time, real-time digital processing. When it comes to Python or any other codes, it's not there yet. I'm pretty sure sooner or later we would get that, but as of now, C++ is the way to go. All right. So yeah. So coming back to the So coming back to the digital equalizer, so we can see that when I boost a certain frequency, so like for example, I'm boosting 300 hertz by almost 15 dBs right now. We can see that there's a pretty wide notch that's appearing here on the 300 mark. All right, and same thing with 500. The only thing that I'm doing is I'm placing a high pass filter and a low pass filter together, and then that has been processed parallelly, so that everything else before that and after that has been let through free. So in this so that's how this works. So how do you emulate certain tonality? So tonality emulation is when it comes to so when it comes to parameters, so tonality is something that is affected due to the parameters that has been set on an analog device. All right, so our parameters as well as the circuitry of the analog device. So all people say that, oh, SSL has this thing, because the only reason you get that sound is because it's been designed in that way. And in a digital plugin, you can do this exact same thing by getting the exact response of the digital the analog plugin, and just emulating the same parameters onto your digital plugin. So say that if my user goes around above a certain volume, I want it to saturate. You can add that as an if statement on your code. Or if someone says that the cutoff frequency of this certain thing is not exactly 6, or it's probably 7 or 8, you can adjust that on your parameters as well. I will get into that a little more detail when I show you the code for the digital plugin. All right, so yeah, so this is how it looks like on the UA, and I don't want to save that. Okay, so right now I have Producer open. 1 second. All right, so Producer is basically a compiler. All right, that I've told you before. It's a compiler which contains all of your source files, and it contains the modules, in this case the DSP module. All right, because we are doing digital signal processing. And to edit all this, you need an IDE. So an IDE is an integrated development environment. All right, so in my case, since I'm using a Mac OS, I'm using Xcode. And if you're using Windows, you'll be using Visual Studio. Or if you're using any other software, if you're using Linux, I'm not really getting into that because Linux has their own thing, and I'm not really knowledgeable on Linux operating systems. All right, so we have the plugin processor, the .cpp file, which is also known as the C++ file, and we have a header file and CPP file. I think if anyone has basic knowledge on coding, C++ would understand this, but for reference, I would say it's like just like a metadata file for the CPP. I think if that helps to understand that. Okay, so we have the editor, which is also known as the UI, or I would say as the UI file. All right, so over here we could say that I mentioned the amount of the different types of sliders I want, the different types of the labels that I added, the different values that has been extracted from the thing. All right, apart from that, we have the then we have the CPP file, where we define everything, where everything is kept, where, for example, what kind of vertical drag, what kind of dials they are, or if you're making with a certain UI, you can add images. Okay, so you can point to the image file that you're using on this code. All right. And the size of your plugin, how big you want it on your screen, right? The user adaptability, where each dial has been placed. So over here, we can say it's been placed at a certain height and a certain width of pixels. All right. And that would be it. So now I think, sir, we can get into like making like a basic plugin. I think that would be fun.
Yeah, but before that, Joel, if you could just tell everyone that what one would do, because see, it's very hard to understand this since a lot of us are not from the technical background.
Exactly.
So as a layman who just don't know, from where to start, what would you suggest from where to start?
Okay, so when I started this, I had no idea on what I was doing. Mm-hmm. All right, I had no experience, and for me, I'll compare it to me learning how to mix. I would say you need to get in, all right, to understand what you're doing. All right, so I would say if you can learn like a basic C++ thing, all right, there are sources available online like W3 School or Code Academy, which teaches you like basic, like bare bone basic C++, which I would say is more than sufficient. All right, but to start off, not more than sufficient, but to start off, that would be more than sufficient. All right, and from there, you could actually start working or get an idea for a plugin that you want to make. Start off as basic as making a gain plugin or a single one band EQ. All right. And then then watch a tutorial online on how someone implements it. And trust me, there are a lot of tutorials online on Juice. And I believe Juice. So Juice has their own forum. All right, where you can see how everything has been implemented. All right, so you can learn Juice. So there's an option to learn Juice right here. All right, you can watch the tutorials. All right, you can getting started with the producer. There's everything on basics on how to start, written down and documented in a timely way. So the only thing you need to do is click the next button. Understand, just take your time. You don't have to force anything to do super fast. All right. Just take your time around, like just read everything. All right. So getting starting, like, from downloading Juice to installing Juice. All right. And then eventually creating like your list. So when it comes to creating all of these codes that I've done, all right, this is not unique at all. All right. This is just me calling the module. So basically saying that someone at Juice has developed all of this stuff. All right. The only thing I'm doing is I'm calling it from point A, saying that, hey, I want you, and keep it there. All right, and just place it at a certain place where I want it to be placed. So it's more like imagine it like playing with a block of Legos. All right. It's available to you. The only thing you have to do is place it the right way that you want it to be done. That is it.
Right. Because as per my knowledge, Juice is a own language in itself. Because not exactly, but yeah, it is based on a C, but it has its own, like you said, you're just calling components. So that's how does the C help you coding in Juice then? Like, is it really necessary to learn C or C++?
So the reason I would say to learn at least the basic of C++, like the bare basic, is because there's a lot of ways. So when you look at the starting of the program, you see that it's calling in a certain way, like hashtag include, which is the basic of C++.
Right.
There's the constructor. So you don't know what a constructor is unless you learn that's just the basic bare bones of a C++. What is an end if, or what is a loop? What is a for loop? How do you call an if and and statement? All right. So those and all are basic C++ that I would use. All right. Just so that you understand what you're doing. And when you want to find out, for example, you want to place a slider. All right. You want to place a slider, but there's a documentation here of Juice, all right, which teaches you on how to do the slider as well. But you need to know on C++, just the basic, so you can search the right keywords to understand what you're trying to get.
But are there any, like how we have presets in any plugin, right?
Yeah.
Like tomorrow, if I open a compressor plugin, there'll be like vocal compressor preset, so that gives me a reference basically, at least. So is there any plugins like this in Juice, or how it works?
So Juice has their demo plugins, but those are just so you can learn how each plugins work.
No, right? I mean, plugin as in, see, now you're showing me how you coded for the slider, and you're calling sliders. So now, did you do that, or it was already pre-coded and you just dragged and dropped the presets from the Juice?
So how do I exactly explain this? So imagine Juice as imagine Juice as like a floor plan. All right. Okay. There's nothing on it. All right. And imagine the code as a floor plan. There's nothing on it. Juice are your building blocks, or basically your presets in a way. All right. So you can always call those presets into your thing. All right. And then say that, oh, my slider. So Juice has a thing made for sliders. Juice has a thing made for this thing. If you want to go out of Juice, you can do that as well. But in that case, you need to create your own modules. So when it goes here, you can see modules.
Right. So this is what I was asking. Maybe I can just get these modules into my program. Yes. And modify them according to my preferences, right?
Yes. So Juice, these are all the basic Juice modules that they provide when you install Juice for the first time. All right. And like the basic audio devices, how the basic formats, plugin client, the core, the data structure, DSP, events, graphics. All right. These are all the basic things that has already been coded by Juice, and you can always create your own, or you can always use the Juice's one. And right now I'm just using the Juice ones.
Okay. Well, how about, let's say, I mean, just a thought, how about if I want to make my own module, so then I need to know whole, coding.
Then you would get to know, then you need to understand on exactly how C++ works, because the modules are, again, let's say it's again like the back end of like how this is the back end of a plugin. The modules are the back end of the code.
Okay.
I think that would be a more detailed explanation. So I haven't, personally speaking, I haven't gone as far as the module yet. I do plan to go eventually, but as of now, this is just the code that has been available.
Okay. Thanks.
So again, that's how code works. All right. And then you have the processor, which is doing your processing. And I think we can start with how to make like a basic.
I think once we start that, many things will clear out,
Yes.
How to start and how the modules are working also.
All right. So first things first, we'll have to download Juice. All right. So you can just go to juice.com/get-juice-download. All right. And depending on your operating system, you can always download it. All right. And if you want, you can download an alternate library for Juice, which is on GitHub. All right. You can always download the frameworks of Juice on GitHub if you always want to keep it updated. There's ways on how to install this properly. So that's how. So once you download Juice, all right, you get two files here. Juice Pro Juicer, and you need to have Xcode as well. Or Xcode is Apple's IDE, or the development environment. All right. So once we open Pro Juicer for the first time, okay, we get a new project screen. So this is your new project screen. Now over here we have different types of things. So if you want to make a GUI, you can make an audio, you can make a console. This is not the mixing console. You don't need to get that confused. This is like the terminal that you get on your Mac, or the command prompt on Windows, those kind of consoles. Animator or OpenGL, which I'm not really experienced with OpenGL, but in this case we're making a plugin, and we have the basic plugin. All right, format. Let's just create, just use the template. All right, so it selects when you're using the template, it selects all of the required modules that you need. All right, but I think you need a DSP module as well, so let's check that, and we can create a project. So let's create like a one band equalizer, one band EQ. All right, let's call it one band EQ.
If
Yes.
we miss out any of these modules while creating a project, is it possible that we can add it later on?
Yes, you can. So that is why you have the modules right here. Okay, you can add, see, you can always add a module, and depending on where you saved it, you can always add a new module. So just like how, you know, you can add a new plugin whenever you're doing your mix, you can add a module whenever you want. Okay, so yeah. So now once you're here, we see that we have a source file, and the source file has 4 different files. So we have the CPP file. Okay, you have the header file. You have for the processor, this is the DSP, and you have the graphics side as well. All right, so now I'm going to open this in Xcode, which is our development environment. All right, and here you go. Oh, sorry, not this one. Here you go. This is how the Xcode usually looks like, and right now it's just processing the files. Give it a second. All right, so our new project is ready. So once you go into the source, you see that Juice does a really good job in teaching you while you do your own project. So I would say, like, whenever you want to learn something, get into it. All right. Such a way that you think of a project and then do it. And that way you learn on how to do something. All right. So in this file contains the basic framework for the Juice code processor, or the plugin processor. All right. And it says all the green things are notes which the Juice developers have given you, saying that, hey, this is where you can check if the layout, some plugins, such as GarageBand versions, will only load some plugins in stereo, but bus layouts, like, those are a lot of, tiny details that these guys, which Juice has done, which I really love. All right. With helping you out to start your basic plugin. All right. And you should use this. Okay. So there's a lot of stuff when it comes to that. So first things first, we have nothing here. So we need to go to our product, your scheme. All right. We can edit the scheme. So what is a scheme? So scheme is the way you compile your program together to make it into a .component or a .au, .vst file. All right. So right now, let's say I want to launch this on Ableton, and I'm just using Ableton right now. So I'm just going to launch it on Ableton, and I'm going to turn off debug mode on, because Ableton does not like to have debugging on. It won't recognize the plugin if it's a beta version of it, because I'm not sure why, but Ableton does that. So I'm just opening up on Ableton, and I'll just close it. So we have the new project. All right. So first things we have, so I can actually compile this right now, and we can see what we get as a basic thing that Juice has already done, like the basic framework that Juice has already done for us. And it's compiling. Sometime. Oh. Yep, there we go. So we get the build successful, and it launches Ableton for us. And all of your plugins would, instead of VST, all right, so right now we're doing a new project. So it's right here, and you can just load it up, all right, onto your audio file, audio track, and you have a new plugin. And the only thing on this, it says hello world. All right, where is this coming from? I'll show you guys that as well. All right, so right now when we go here, oh, sorry, my bad. Yeah, so when we go here into our graphics, we see hello world written here, which is like a draw fitted text, which says hello world with, font of 15 pixels, and it's white in color. All right. So so because of that, we can link saying that, okay, so this must be our UI, or where everything is placed on your computer. All right. Sorry, on your plugin. This is where you see this is placed there, or this is, all that stuff. So let's start by, let's get a basic, like a single dial, a single knob, I would say. Or okay. So in our plugin, we see this. So let's close Ableton right now. All right. And let's get back into, All right, there we go. All right, so let's get into this. All right, so let's say I want to add a slider. All right, so slider as in slider is used for a lot of things, especially when it comes to juice. You use sliders in, as a knob. Slider could be a knob, it could be a fader, it could be, it's a knob and a fader. That I think that could do a lot of stuff. All right, so when we go to our, let's go to a juice, we get our class indexes. All right, so these are basically the basic code that has been available online for you to search and use. So let's say I want a slider. So I'm just going to search slider and we get slider, right? I can go to the slider. All right, and this is how the slider works. All right, so we have a lot of things about sliders. So once you know basic C++, you'll understand what classes are, what member functions are, what enumeration documentation are. Like with basic C++, you'll get a true understanding of what it is exactly. But right now, I'm just gonna ignore all of that and assume that we'll get to that later, okay, on our own. All right, so we can see that we have look and feel methods, like to make look a certain way or feel a certain way, like to have, depending on if you move your mouse fast, the dial moves faster, or if you move your mouse slowly, the dial moves slower, with velocity and all that stuff. So let's start by getting a basic this thing. So right now we have nothing called into our project. So let's now call in a device. So let's call in this thing. So over here we start by writing juice slider. All right, and let's name the slider. So let's call it, give us a hertz that we want to change. All right, let's call it frequency, or let's frequency this thing. All right, and we get another juice slider. We have the Q factor. All right, so I'm just writing Q. Q slider. And what else do we have on like a notch frequency? We have the frequency, we have the Q, and we have the gain. All right. All right. So right now it says that, so whenever we do any error, Xcode will let you know. All right. On how it is done. So for example, over here, I missed out a semicolon, and Juice will let me know on that. And semicolon is pretty weird error that usually people get. All right. All right. So now we have called three different stuff together. So the only reason I'm writing M in front of it is just to know that these are things that is made by me. All right. This is not Juice's thing. This is my label that I've given to a device that Juice has already made. All right. So I have made three different labels here. All right. And after that, I'll go into my plugin editor. All right. And I can, so when you go to the class list, you can see that you have all of these member functions that you can use. So you can set the rotary parameters, you can get the rotary parameters, get mouse sensitivity, set the mouse sensitivity. All right, so let's start off with getting the slider style. So these are all the slider styles that Juice has made for you. All right, so we have the linear horizontal, which is basically a fader. Sorry, which is the back to forth fader, a linear vertical, up to down. Then you have the rotary, which is also known as a knob. So let's in this case, let's make it a knob. All right, so let's make it a horizontal vertical. So what we can do is we can just copy this, all right, which is the enum style, right? Copy. And I'm going to go into our Xcode and I'm going to code right here. So I'm going to set the deal for our frequency. So M frequency. So we can see that, you see how Xcode brings up the thing for you. All right. So you defined it on your H, this thing over here. All right. That will pop up here as well. Sorry, Q. All right. Dot. I'll set the slider style, so everything pops up to you. All right, and it brings up how the thing is. All right. So just like how over here, set slider style, and how the code shows up here, you see, all right, that pops up over here as well. All right, because it is connected to the juice module. All right, and let's say slider style, and I want to make it a rotary, horizontal, and a vertical drag. So even if you drag it vertical or horizontally, horizontal, vertical drag. So you can see here, it's a rotary control that you can move by dragging the mouse up, down, or left to right. All right, so let's use that. All right, just copy paste. All right, and semicolon. Make sure that is there. All right, so so what are these double? I believe these are colons, right? Yeah, double colons. So basically, what they do is it's basically pointing into a certain direction. So just like how in Windows we have the brackets that show us it's in this file, into this folder, into that folder. So we can say that in Juice there's a slider, there's a slider style, and in the slider style I'm picking the rotary vertical drag. All right. So then we can set like, so, but just with the dial, you can't really do much. You need like a text box and everything, right? So there should be slider. So you see here how, so set slider style, get slider style, set rotary parameters, blah, blah, blah. You can set, there's a huge documentation. Just need to read through all of this once. All right. I'm pretty sure you'll get everything. All right. Depending on how you want it. All right. So in this case, let's say, okay, 1 second. All right. So frequency. So in the on the frequency thing, make sure the spelling is right. All right. I want to set the style box as well. So this is basically telling me that text box below, which is here. I think I can just text box. Yeah, text box style. So we can see that it's a slider of the text box slide and what it does. So it's the entry position. If it's read only, all right. So if the person can only just read but not type it in, and the height and width of the text box. And we can just set that. And with the text box position, let's say I want to position it below the text box as well. So that happens here as well. All right. All right. So that's why I say text box below. So it's below the dial. Then we'll set the range of this. So frequency. All right. Dot set range. All right. Then we have the minimum and the double. Sorry, minimum and the maximum. So let's say 20 hertz to 20. That's 20,000, right? Yeah, 20 to 20,000 hertz. All right. 0. Oops. All right. All right. So now in the set range, there's actually 3 parameters in set range. So we have the lower value, the higher value, and the minimum amount of change between them. So let's just say 1 frequency for each. So I don't want it to be, like 20 and a half frequency. That makes no sense. So let's keep it at that. Then let's we can frequency. We can just set the value, which is so when a plugin is launched, what value do you like it to start it off? So let's just say 1,000. All right. Let's call that a day. And I think this should be pretty much it. My bad. Set value. There we go. All right. So now we've set the stuff for the frequency. Now we can just copy that same stuff over. All right. And let's set it for the Q factor. All right. Q. MQ. That pops up and just Q. All right. So, but of course, the values of the Q factor would change because Q factor would have, different values as well. So you can't really have a Q factor from 20 to 20,000, right? So let's change the value of Q factor. So let's say 0.5 to, let's say 10. All right, I think that's a pretty narrow Q, like, you know, like a fab filter Q. Okay, and then the value, the set value of the Q would be, let's just say 0.1, let's say, or 1.0. Okay, so this F that I'm writing right now, you can see it's there on most things. M dot software. No. Oh, my bad. So this F that I'm writing now is just telling the thing that that's the final number, like that there's no integers after the decimal point. All right, so just so that, you know, the computer doesn't freak out. Set value. Why isn't this? All right. So now we've done the stuff for the Q factor as well. So now let's do the same thing for our gain value. So M gain. All right. M gain. Gain. M gain. All right. So, but M gain would have, you know, different factors. So let's just say minus 15.0 F to positive 15.0 F, and the value would be 0.1 F. And the range, we don't want it, you know, increasing the gain automatically. So we want to start it at unity. All right. So we're just starting it at unity. All right. And then, all right, I think that this is it. Basically, you have three different values that is popped up. Capitalize the F, and that's the reason why that was showing me an error there. All right. So right now we have called up. Wait.
It's V value F value. No, value is V is.
All right. Thank you so much. That's the thing when it comes to coding. You have to get each and every single thing correctly. Otherwise, you get errors. All right. So yeah. So then I'll say that I want to set the size of my, let's just say, box, right? The window that pops up. So let's just say I want it, let's say 600. All right. 600 pixels by 300 pixels wide. Okay, and I want to set the size limit as well. So I don't want someone increasing the resize. I don't want someone to keep resizing the same thing. So I'm keeping the maximum and minimum and 600. That's it. All right. So right now we can run this code, and but we won't be able to see any of this because we haven't placed them on the device yet. Right. So now how do we place that? So now we have the graphic option right here, right? So on the graphic option, we can say that we have our color. We have, so let's just say, actually, let's get rid of all of this. All right. Let's just get rid of all of that. So let's get in like a simple, I have a preset thing. I can just copy paste right now. I'll explain it to you guys. All right. So let's just say that I have a rectangle, all right, with this much width and area. And I wanted to color, the background color would be black and the text color would be white with the size of 14. Okay. That's basically how the background or the background UI is. All right. Now over here, you see this resize. So this is what and all things that are going to happen inside your plugin. So right now we have three devices. So let's place those three devices here. All right. So let's just say M frequency first, all right, which is our first dial. All right, or we'll keep this as a center dial then. All right, set bounds. All right, capital. All right, so we get set bounds. All right, see, we get set bounds here. So we have the X and the Y axis where it's been placed and the width and height of the exact thing. So let's just say width, I'm giving it 150 pixels and height, I'm giving it 150 pixels as well. So a little bit of math here. All right. So let's just say if it's 150 pixels wide and 150 this thing, so we can get the height. We can see it's a constant of the thing, which has already been mentioned before, which is 600. So we can get the height and then divide it by 2. So that gets it in the center. All right. But the center of the diag is always a little bit above. So let's just say minus 75. Right. So it comes exactly in the center of the height. Upar se niche. And then from this side, let's just say I'll place it at 50 pixels. All right. And then we can just copy this and paste it 2 more times. All right. But in this case, it'll be MQ. Right. And MGain. All right. So, but you can't keep them all at the same place. So let's just say this is 50. 50 plus 150, which is 200, so it'll be 250. 250 plus 150, let's just say 500. All right. So that's where everything has been set right now. All right. So right now, let's run the code. Let's see what we get. All right. Let's see what we get exactly. So hey, it's successful. Congrats. So we get, so everything, all of your VSTs and audio units are saved under your company. All right. And you can just launch it in. Right now it says hello world. Okay. I think it didn't scan properly. 1 second. Yeah, make sure you have your VST2 folder that has been pointing to your juice, because when you build a plugin, all right, so one band EQ, it's a new project. All right, it's in here, and it's in the source file. So the source file in your builds, right? You have your component and your VST as well. So it needs to do that. Okay, still loading up the old.
You can choose any other DAW also, right? When you
Yeah, you can definitely. So for example, actually, let's try that. Product scheme. So over here, let's just say I can choose other. Let's launch a Logic. Sadly, we cannot make yet for Pro Tools, because Pro Tools, you need the AX developer license.
Right.
So once you have the license, you can definitely load it up onto Juice, and you can export it into AX as well.
Right.
All right, so there you go, our Logic open. Again, here, like when you go to your plugins, it should be under your company, and it's not showing up.
I think you'll have to scan the audio units and everything.
Yeah. No, usually it should work. Not sure why.
Do you kind of need to build it before it reflects there?
Yeah, we do. So it's basically replacing your old component that has been already been made, and that would replace it, and you can get it in. I don't know why my scheme, I think. So I just need a 16. Okay, it's still coming up as the old one. Well, usually when this kind of issue comes up, that's when you turn to Google. So right now, I'm not really sure. Just hold it up.
So what's that yellow triangle mark that's shown on the right top?
Yeah, so yellow triangle is just telling you there's a discrepancy, or like it's something like it's been like a warning. It's not really an error. So
Okay.
you can avoid, if it works, it works. If it doesn't, then you'll have to probably like look into it. But so right now it's just pointing that the DSP is not plugged in anywhere. All right, so that's why you haven't really used your DSP. That's why it's warning you that you haven't used your DSP. So you'll get a lot of yellow warnings. That's completely fine. Okay, it's still showing up the old one. Where's my producer? My producer is not showing up.
I think you just minimized it.
No, that's a different project.
Okay.
Okay, it's still coming up the same way.
That's fine. If you could show us this, I can see there's a gain knob and other projects are there.
Yeah, so I have other projects. I think I'll have to probably look into why that's happening again. Okay, so yeah, anyway, so I guess we'll just continue again and I'll show you how it exactly works later on. All right. So, okay, so right now what I've done is I've set the dials. I've set the parameters of the dial. So this is basically where all your parameters goes in. And this is your graphics part of it, like what's in the background. And then we have what is exactly in the, where every component is placed. That's why it says resized here. All right. All right. All right. So next, let's start working on like the DSP model of it as well, actually. So that will be much easier to explain. So, so right now the DSP model, let's go into the class reference ones. They're the index. Class index, yes. So right now, see, we have a lot of indexes right here. So we have ADSR parameters. So you can make your own synthesizers with Juice, and there's a lot of stuff you can do with it. So right now I'm trying to make like a basic IIR filter, but let's just say an IIR filter. So I just need to write IIR, and yep, IIR filter should pop up. So let's go to the IIR filter. All right. No, sorry, this is not the audio IIR filter. That's a different IIR. DSP. All right, here we go. So this is basically how IIR filters are. This is how basic different types of filter designs work. So these are already filters that have been designed, all right, by Juice, right? And we're just calling them into our program right now. And so when it comes to emulation of, plugins, when it comes to Waves or UAD, they have their own filter designed by someone. Someone has coded the designs for them. And then someone else is calling it for it. So instead of, we are right now using a Juice module, they might be using the UAD module or their own module. And that's how they get the emulations working, all right? So let's just say I want to be a notch filter. So should be FIR. Wait. IR coefficients. Yeah, there we go. So IR coefficients, we have the make low pass. We can make another low pass, but with different, you see how there's different parameters of it. We can make high pass with different parameters, an all pass, or we can make like, so basically an all pass is like a bypass switch or something that you can make. Then you have the high shelf, and let's just say in this factor, we want to make a peak, which is like a simple notch frequency. So we can make like a peak, which is, where is it? Yeah, so this is basically your code for making a peak frequency. All right, and you'll see that how it's the sample rate, center frequency, Q factor, and gain factor. These are some things that we already know as audio engineers, and this is what we set for other audio engineers as well. So that's how the terms comes around. Return. So basically, so in code, when it comes to multiplier, so gain when it comes to code is basically a multiplier. So in code, we don't really talk about in decibels as such, right? We always talk about in multiples. So if it's 1, it is everything times 1. So that would be unity. If it's 0, it is anything multiplied by 0 is 0. If it's times 2, it is twice the signal. If it's times 3, it's 3 times the input value. All right. So I think we'll have to take that into consideration when it comes to working with audio plugins, because it's not made that way. And the only reason we get decibels in our plugins is someone converts it into the decibel format and then gives it to us. All right. So before starting our plugin, we'll start with the plugin processor basically, and we'll start up on how the plugin processor works. So which is the process block right here. So we can see how there's a total number of input channels, this is setting the thing that the amount of input channels is the amount of input channel that we have. So if it's a stereo, mono, multi-track, whatever. All right. And there are notes given up here by the Juice developers to, get exactly what we want. Okay. So, over here, we can also get the channel data and all that stuff, like it's a buffer. So first things first, let's get the DSP module ready. All right. So there's a tutorial on Juice itself on teaching us on how to get the DSP module ready. But before that, we'll have to create a value for the process, which is known as the last sample rate, because sample rate is something important when it comes to audio, right? So it's a float is an open value called as the last sample rate. Sample rate. I just created a thing called last sample rate. All right. Apart from that, then if I go back into my CPP file, where you go? Prepare to play. Yeah. So this is the place where I need to work. All right. So we just like how we saw earlier. All right. On the prepare to play. So let's just say last sample rate pops up is equal to sample rate, which is a constant that's just going to come from your DAW. All right. And let's just call the Juice Dsp module. All right. Process spec and spec it up. All right. Then we call this sample rate. All right. So all of this stuff is available on the Juice module. If you go into the tutorial section, all right, there is a tutorial on how to prep up the DSP module. So the synth, audio player, processing input. So you would get a proper way on how all of this is done. So right now, just to save time, I'll be copying it a little bit and from an earlier build, and I'll just be pasting it here. All right. So the number of channels, the samples per block and all that stuff, because digital audio works with samples. All right. So now we have the module prepped up. So now, just like how we call the sliders, we need to call the DSP modules as well. All right. So let's say, so right now we have one filter that is working right now. So let's just call that filter. So how do we do that? So just like how we go in the class list. Yeah. So IR class reference, there is a code which basically says how to call it. So it goes something like this. Use DSP. So again, it's pointing to the DSP module. It's up. So right now what we're doing is we're just doing like a processor duplicator kind of stuff. So basically we're using a processor duplicator because if you're working on normal listing, you have stereo files, right? So we're using stereo. So we'll have to copy the file over again, do the same code twice to get the same effect on both your channels. But now since we don't want to do that, we're just going to duplicate the process and using that process duplicator to copy it over, right, to the stereo file. So DSP, which is the IIR filter. All right. Filter, just write type float. All right, and now we'll state the this thing as well. So let's just say, so now this is where we name the plugin, the filter as well. Yeah, and giving it a coefficients. Again, type float. Okay, and then we'll name this as notch filter. So if you have multiple notch filters, then you'll name it as notch filter 1, notch filter 2, blah, 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 so on. All right. And then semicolon. And so right now, since you're just working with one filter, just name it this way. And I have an error. All right, that should work. All right, so then let's go. So once you called it from the type, okay, yeah, there we go. It fixed itself. Okay, so once we're done with that, all right, so then we'll try to edit it in our process block, which is your CPP file. All right. So before doing that, we need to call it in our constructor. So we need to call it, constructor is up here. So right here. So we need to call it within us thing. All right. So basically it's a peak. We have our notch filter. There we go, shows up. And then the arguments for that. So it'll be juice. All right, DSP. All right, IR. And the coefficients. Now we'll talk about the coefficient type. So right now, since you're talking about a notch filter or a make peak filter, so coefficients, wait one second. Load. All right, so then we'll just make a notch pass or make a peak filter basically. Peak filter. There we go. Now we put in the basics, this thing, which is 44.100. Just this is not how it's going to work. I mean this is just calling the constructor. Then after the constructor, it will change to the, so C++ always reads from top to bottom. So this is just initializing the plugin ones, the filter ones. All right, and now we've called in that filter. All right, so then we have the audio processor. right here. Okay, right here, we'll be adding like a range. We're adding the range for each of the components that we are adding, right? So just like how we did in the earlier thing. So we have the normal sizable range, right? Which is type float, which is open. And let's just say, oh, before that, I think I forgot about one thing. Okay. No, I didn't. Yeah, type float, we have the frequency, all right, which is from 20 to 20,000. All right, with a step value of 1.7. All right. Then we have the same thing. I'll just copy the same thing. All right, instead of frequency, it'll be the Q factor. Except the Q factor over here would be 0.5 to 10. And it'll be 1 divisions, right? Then we have the, let's copy this again. Right. So Q factor, it'll be last thing in TMG. And gain would be, let's just say, okay, so since you're talking, so in this section, we'll be talking not in decibels, we'll be talking about gain factor. So let's just say, actually, we can write it in decibels. So let's just say minus 15.0F. All right. To positive 15.0F. And 0.1F. All right. So that's how we got that. All right, so I think since we have called all of that, so we'll have, okay, now the next factor that we're going to do is we're going to make it and add it as a parameter to that someone could edit it. So this, which will again connect to your the UI that you made before. So you get a processor called tree. I think I missed something. So tree.create and add parameter. So it looks something like this. I'm just copying it from the class index. All right. So right now, let's just say I'm calling it frequency. So you might be wondering why we're writing this 3 times, right? So one is for the device, one is for metadata, and the other one is like when you have automation and all that stuff that's happening. So it labels that, so you can send output to that. So this will be your frequency. All right. Then we can just again copy and paste it again for the other 3 parameters as well. So except the frequency will be Q and the gain. Yada, yada, yada. Okay. I'm not really getting into the errors right now. I think there's going to be a lot because I'm just rushing through this. All right. So basically, we're just calling it up. All right. Then the next thing we'll be doing is we'll be calling them into the filter. So we'll be creating a new thing called as an update filter kind of thing. So it's basically connecting your filter to the DSP module. So I believe we need to go to your plugin processor right over here, which is your common. We'll be adding a few things. So we'll be adding update filter, and we'll be updating the parameters as well. All right, and so audio processor. Yep. So this is why I was getting an error earlier, because I didn't mention this here. So I'm just calling it a tree, and that should eventually fix this up. Yep, there we go. Okay. So yeah, so now since we have mentioned all of that, all right, now next thing that we're going to do, yes, and I mean mgain. Thank you. Okay, so next thing that we'll be doing is we'll be calling it in our DSP module. So how like how we set this up, we got the process block, right? So over here in the this section, delete all of this. All right, do something. So it says do something to the data. So that's what we're going to do right now. All right. So we'll call the juice DSP the audio block, all right, which is going to be type float, and we'll name it as block. All right, and then we'll say we want to update. Okay, then we'll call the filter that we made, which is called as the notch filter. All right, and we'll process it. Process. Then we have the remember how we're replacing we're duplicating it from one for the stereo channel, right? So we got the process block. Here we go. Oh, and I messed up. Supposed to be after this. There we go. All right. So we've got that running. All right. But every single time we want to bring up a filter, we always need to, call in its value. But the thing is that if we don't reset the time whenever we send past audio through it, it's going to keep getting, sending up garbage values, which we don't need. Right. So for that, we'll be resetting the filter every single time. So over here in this prepare to play area. All right. And I missed yep. All right, so we'll add like a notch filter. Oh, my bad. Notch filter, okay, and we'll prepare it. All right, and then we'll call it spec. And then we'll call the notch filter again. All right, and then we'll reset it. And that should be good. All right. Then, okay, so now we'll be adding a new thing called as an update filter kind of thing right here. All right, so this is the process block where we're doing all the processes. So we can add a new thing over here called void, which is then we'll call a project, which is our new project, audio processor. Okay, and then we'll update the filter. Comes up, and then we'll add an R. Okay. So these are all floating values that we can add in. So we're calling it a Q, or float Q, which is our tree dot get parameters. Oh, my bad. Semicolon. Okay. Get raw parameter value. All right, and that's our Q. Okay, which this is the thing that we have mentioned here. All right, up here. See this Q. And then we have another floating value, which is our gain. Right, again, which is going to be like tree dot get raw parameter gain. Right, then we have another float, then which is our frequency. Let's copy this. Frequency. All right. And yeah, so right now it says it's unused variable. So we haven't really used it. So we created the variables and we have connected them to our dials. So now we need to just connect them to our variables. So now let's create the variables. So let's just say notch filter. Let's create a notch filter. All right. This is now the exact processing when it comes to it. All right. So notch filter. All right. Dot state. All right. So now we're calling the juice filter. Right. Juice Dsp. All right. Again, IR filter, which we mentioned before, which is float. Make peak filter. Now we get into the fun part. So what is our sample rate? So now we mentioned that sample rate is again over here, last sample rate. Right. So we'll just write here last sample rate. There we go. Now we need a center frequency. So frequency right now is set by this. So we can just write frequency here or freak. All right. Now Q. That has also been our parameter, which we mentioned here, and then gain. Done. Yep, and cool. And that should be it. So right now,
just two brackets. You
uh,
have to gain.
no, I have to put. Wait a second. I messed up a little bit. Okay, so there's another thing though. So right now gain, all right, the gain value that we have right now is in decibels, but decibels will not be able to calculate. Decibels or a negative value is not, able to calculate with your filter. So this is when the role of decibels come in. So right now when we go into a class list, all right, you can do the calculation manually, but Juice has been kind enough to do the calculation for us, and they've given us this thing called as the decibels class. All right, so we can basically convert decibels to gain factor or gain factor to decibels. Right. So right now we're converting decibels to gain. All right. So because over here we mentioned it as decibels right here. So 0.5 F. These are decibel factors. All right. So this gain over here that we have, all right, it's coming in as decibels, but we need to convert them into gain. So we call it the juice decibels. Okay, there we go. We get decibels to gain, and then we type in our gain value. That's it. All right. So now we had our decibels to gain working, and I believe everything should be up to date as well. And you do, and that this is it actually. You basically have made a basic plugin. You can compile it, but I'm not sure why it's not. Yeah, it's my Ableton is doing something wrong. Let's open that. Let's see if that works. Does it? Okay, so while this is scanning, does anyone have any other questions? Okay. I'm not sure why Ableton's not picking up my. It is picking up my older plugins for some reason.
I think that's fine because yeah, we all know that it takes some time, and yeah, there might be some couple of errors also.
Okay, wait. I'll do one last thing. Let's see if this works. That's it's not loading up the new. Well, yeah. So basically, this is how it actually works exactly. So this is how so right now what we have done is basic plugin, which it's all available online. It's all available online here. All right, on the Juice class index. All right. And if you guys have any other questions, you guys can always reach out to me. All right. Whatever I know, I'll help you guys out and point to the right direction if you guys are interested in making your own plugins. And trust me, if you want to learn it, you just have to get into it. And if you understand what you want to make, you will search what you want and eventually get into it. That's what I would say.
Where do you like, if we could, Joel, now at the end, if we speak about the Equalizer plugin you showed us.
Yeah.
Where are you exactly there? Before we end this session, if you could tell us.
Sorry, I didn't understand the exact question.
So the Equalizer plugin you showed us, that you're in the middle of building that. So where exactly you are there now, and is it fully functioning or?
It should be fully functioning. I'm not sure why it's not, that my DAW isn't detecting it for some reason. My DAW.
Not this one, the Equalizer, you already made it.
Oh, this one?
No, the plugin only.
This one?
Yeah.
Yeah.
The graphic EQ. Yeah.
Yep.
So is it like fully functioning now, or?
It is a fully functioning graphic equalizer with a set Q. All right. So now we can actually go back into the exact code for this, and now it might make a little bit more sense to you guys. So when I open the code for the older this thing, all right. So see, remember how we said okay. There we go. Yeah. So remember how we said we first set the dials, all right? Everything is set. We created the parameters for the dials. So we set the slider style, slider box, the range, what we needed, all right? And then these are all extra visual things that I just wanted to add because I wanted to get into it. So you guys can add that as well. All right. And then I said where it's been positioned on the screen. All right. The labels as well. All right. And then after that, I created the filter. So in this case, we had 8 filters, and the one that we are making right now, we only had 1. So I had to create 8 different filters. All right. And then same thing on how we processed it. Okay. We prepare each filter, we get the sample rate and all that stuff. We get the raw parameters. But in this case, the Q factor is same for everything. All right. The gain value is the only thing that I've given control on in the UI. So again, so this depends. So you can take any filter that you want. You can either give it more, all of its parameters, or just the parameters you want to give. And that way you can create plugins that you exactly want. Chain other plugins together, create parallel things. You can do a lot of things when it comes to creating all of this stuff. All right. And then after that, you create the process replacing, and then, and that's it. And, everything from, creating the parameters, it's all good. And when it comes to plugins, of course, you can even automate it right now. So you have 1 kilohertz automation band. So you can even do that. And I believe if you play it, you can automate it.
Awesome.
So that's how Juice plugins work.
Awesome. It's a lot of information, I would say, and the end of the, and I'm sure it is going to take time for every one of us to process it, and I'm sure everyone has benefited by this knowledge, and thanks a lot for doing this, and thanks a lot for sharing your knowledge, and I wish you all the best, and I hope to see those hardware plugins and everything again with the UI and everything.
Thank you so much, sir. Like I'm glad that you guys could give me this chance to share my knowledge with everyone, and I hope other people will be inspired to start into plugin development as well, because it's a huge field and there's not a lot of people doing it as of now.
Right. Well, that's the idea. That's why, like I said, I'm glad that you did it when we were talking long time back about it, and you started doing it. I'm glad that you are somewhere you're somewhere near to making your own plugin, and good to know that. And once again I wish you all the best, and thanks a lot once again for coming today and sharing your knowledge.
Thank you so much, sir.
I hope other people will start, like you said, and we'll see more and more of these, devices and plugins. And we'll definitely, do 1 or 2 more sessions in the future. And, because now, I know this information, there's a lot to speak about it, and there's a lot to, do about it. So,
I'm pretty sure it must have gotten a little boring for the people who didn't understand it, because it was probably going a little bit, above.
Right.
But I'm pretty sure once they start into it, right, like, it was, of course, confusing for me as well when I first started off. Like, I had to see the same tutorial or the same file. I had to read it like 25 different times to finally understand, oh, that's why you do it. Right. So it does take a little bit of time, but I personally feel that time is worth it at the end.
Absolutely. Especially, utilizing this time when you're at home. I think it's the best idea to do it right now.
Yep.
Good. So that's it, Joel. And